So I've been asked to talk about the Square Kilometer Array Observatory, which after, it must be 10 years of stuff. I remember 2012 it all began to kick off. It's now 2022. They're finally building it. So they're finally building two telescopes, radio telescopes, one in South Africa and one in Western Australia. It's still a big data project, and it's very much an exascale project. One of the things I will say is that a lot of things, especially Andy's talk, is very pertinent to how our thinking about how we do this has changed over the last decade, and it's pretty well tracked what Andy was describing in his talk, actually. It was a great talk, Andy. I could have done without the flashbacks though, because the only time I've ever lost my temper at work was with, I'm being recorded, aren't I? With a certain three-letter cloud company. Okay. Martin Hamilton witnessed it, as did Brendan Boothler, which is really giving it away. So I'm going to talk about the UK's response to this. So I'm going to kind of give a ground-up view of what we will be doing in the UK. So the first thing you'll notice on this list here, you've got Durham. These are all the partners, and they'll all be doing stuff for it. This is a distributed project. And these are all the names. Some of these names you will recognise. So there's Wes Armour from Oxford, there's Paul Kalasia from Cambridge, there's me. Mark's name isn't on it yet, but it will be. So Catherine said earlier it's important that we know why we're doing it if we're actually going to do this efficiently as well as effectively. And the vision is basically to enable UK scientists to lead exploitation of SKA data by meeting the needs of the UK science community by providing seamless access to SKA data and support. Seamless access. In those two words hangs the tale. In those two words hangs all of our efforts over the next 3 years to get things started. We're going to be part of a big global project, 16 nations, including China and Japan and Canada and South Africa and Australia, India, and a host of European countries, which is called the SRC, the SKA Regional Centre Network, right? And the data that's going to come off these telescopes is going to come off at about 2 petabytes a day, will be distributed amongst us all. And that should be telling you immediately what kind of project this is going to be in terms of IT delivery. So I won't keep you in suspense. It's going to be a hybrid cloud. And within that hybrid cloud, there will be a place for people like Paul, people like Andy, and people like Andy, and anyone else. So just to tell you what the challenges are very quickly, by about 2028, they'll be generating about 2 petabytes of data that will be distributed around the world. This is kind of unprecedented. There'll be another project doing the same in 2028, and that'll be the Run 4 of the Large Hadron Collider, and that's very important to know because they are going to be our main collaborator. So we're going to share infrastructure and ideas with them. One of the things that we will have to deal with are very large data sets. Just so you know, I've done a list of numbers here. As Alistair will tell you, we're about here-ish. Over the next few years, we need to go up to here. This is quite a challenge for the existing kind of the existing storage and server technologies that we need to buy and write code for. we have to do both actually, okay, because everything's breaking. Everything's breaking. So new technologies, both hardware and middleware and software, are going to have to be deployed over the next 3 years. So this is very much an engineering project, and for me it's fascinating because for the first time I'm not a provider of resources. I'm a user of computing resources, and that does change your perspective. Okay, so yes, it does actually. One becomes quite needy, and just to let you know what the challenges are. Here we have the stuff coming in. There's a data logistics element that Paul was talking about, compute storage and platforms scattered everywhere. We're going to have some operations thing that's going on. Andy, of course, will recognise this immediately as what Azure does, right? So, and then there's all this other stuff that is sitting on top of it, which is the sciencey bit. It's the thing that's pointing towards the science community. The archive services, the federated services that Paul was talking about, how we engage with the users. All that stuff has got to be provided. And then I've done this simple diagram over here. In fact, they're both my diagrams, because you can tell that because they're rubbish. And you can see science platforms, applications, workflow, federated computing operators, compute storage, and middleware, and winding through each of those are these activities called data logistics and the science data archive. There, as Antonin says, is a very, very active data environment. So this is a very quick look at how we're going to be approaching these challenges. So we're going to have to get on with doing performant parallel virtualization to allow people to easily run their workflows. People want to have quasi-interactive sessions on supercomputing resources. So this is where we get into these ideas of a larger laptop, again, which are very cloudy terms. But that's the kind of seamless access that we have to start providing. And there's the science portals or cloud portals, workflow management, job provisioning, the data management, moving all this stuff around and collecting it, making sure the work, the executables, containers, whatever you want to call them, go to where the data are. So just aware of time. So what's the timeline to deliver all of this? So we've got a very interesting 3 years to focus on engineering and development. I've finally got my money. I've got 13.2 million over the next 3 years. Well, I haven't, but you know what I mean. And we'll be setting up a project between now and the beginning of April, and the project kind of gets going from January and then really gets going from April of next year. And the idea is that we prototype and design and implement about 80% of the capability, and the UK wants to go for about 20% of what the capacity will be. Of course, one of the things we'll find out is what the capacity will be. So we're going to have 4 hubs initially: Rowell, Cambridge, Manchester and Durham. We'll be generating Pathfinder data at various sites around the world to develop and test the technologies. We've tried using synthetic data, and we found that it doesn't actually lead you to good conclusions. So there's actually now a big observing program to generate these very large data sets, and we're going to have to use some unusual ways of doing that. We're also going to bring in lots of demonstrator projects to help drive and test the engineering. That's for the next 3 years, and then in 2026, assuming everything's on time, 2026 is very important because the SKA even then becomes the most sensitive radio telescope in the world. It'll then become 10 times more sensitive between 2026 and 2028. This is a quick timeline. It's a very complex and busy slide, but one of the great things about it being a radio telescope is you can build a small one, and then a bigger one, and then a bigger one, and then a bigger one, which means that we can, as the thing grows, we can test all the things that we need to build as we go along, okay? Which hopefully means that we'll be able to test and deploy, test and deploy, test and deploy. And what we want to do is iterative co-development of UK SRC functionality. Okay, so confronting what we build with what science data we have, we hope by doing that we'll begin to de-risk what is actually quite a complex project. There is a capital program, which I suspect half the audience is really waiting for me to talk about. I've actually given this away. It's going to be administered by STFC Iris, whose chair is John Hayes. And this money will be provided to people like Mark, to Mark Wilkinson, colleagues in Grid PP, and to Dirac over the next 3 years. We've got about 4.95 million just to actually build this 20% capability, most of which will be a test, will be used for testing and development. And we also have a digital assets program, which is around building the things that Paul was talking about. This kind of dynamic way of presenting services to the users. So these are the demonstrator cases. And yes, this is the important one. So now that I've got some money, I can actually talk sensibly about one of the things that we're really keen to do, and it's 5:30, so stop me soon. So one of the things that we want to do is use this as a way of developing long-term technical R&D and co-design collaborations with technology providers. We've got some pretty good industry collaborations going at the moment anyway, but we actually want to kind of get more people involved. So there is space within both the capital program and the digital assets program over the next 3 years to actually form joint projects with you. And I'll tell you more about how we do that as and when these calls are made. We do training as well, and we want to engage with industry partners at the level that we operate at over the next 3 years on a regular basis. But I think the most important thing that we'll be doing is actually forming co-design projects with you all. And these are the kind of areas that we'll be looking to invest in. So data transfer service, it's not actually about the pipes, it's the things at either end, which is the really interesting and hard bit. There's the archive services. Our archives are dynamic. They'll be talking to other archives around the world again, and things like that. So they won't be giant S3 things. They will actually be much more dynamic than that. There are good old-fashioned compute systems, CPU and GPU. There's a lot of change going on that we have to invest in. Bulk storage, and then this big digital assets, producing the middleware and software layers that we need to, that will help define our service over the next 3 years. So a whistle-stop tour. Sorry, it's been a bit incoherent at times, but as I say, I am the surprise speaker, and it has to be said, I am the most surprised. So there we go. So I hope this kind of brings together a lot of things you've been talking about today. It struck me that it does as I was speaking, and I actually found Andy's talk a brilliant introduction to what I was going to talk about. So thank you for that.